Hi friends, now we are going to solve the second part of our question number 7. So in this part we have to explain the PDA, n-PDA and 2-PDA. So firstly understand what is the PDA. PDA stands for push down automata. A push down automata is a finite automata with an additional memory stack. This stack allows the PDA to remember the information during processing and use it later. Its component. So these are the six components used by the PDA. Final states represented by the Q, stack alphabets represented by the symbols, then the input alphabet represented by the sigma, initial state represented by the Q0, transition function which is represented by the del, and the final states represented by the F. So language recognized. PDS can recognize the context free languages, short form is CFLS, and this language have the property that any string can be generated by repeatedly applying production rules that rewrite a non-terminal symbols to a string of terminals, including the empty string also. Now the understand the operation on PDA. So first start in the initial state with an empty stack and the input strings. Read the current input symbol and the top stack symbol. Top stack symbol. Based on the transition function, it performs three actions. Push a symbol onto a stack, possibly replacing the top symbol. Then the pop a symbol from the stacks and move to a new state. Repeat step 2 and 3 until the entire input string is processed and accepts the string if it ends in accepting state and the stack is empty. Now the second is 2-PDA. 2-PDA stands for two stack push down automata. It is the extension of push down automata. A 2-PDA is a PDA with two stacks. In this push down automata, we use the two stacks instead of one. This allows for more complex manipulation of data during processing. It increases the power compared to a single stack PDA. A 2-PDA has the greater capability. Absolutely, it can recognize the wider range of language, including some non context free language equivalent to Turing machine. It is the equivalent to Turing machine. In theory, a 2-PDA can be simulated by a Turing machine, a more powerful model of computation. This implies that 2-PDA can solve any problem solvable by a Turing machine, but potentially with less efficiency. Now understand the n-PDA. n-PDA stands for n-stack pushdown automata. It is generalization. n-PDA is a generalization of the PDA concept, allowing for n stacks, where n is an positive integer. Means we can use any positive number of stacks in the n-stack pushdown automata. Its theoretical significance. n-PDAs are primarily of theoretical interest, while they can potentially recognize even more complex languages than 2-PDA. Their practical applications are limited. Complexity versus usability. As the number of stacks increases, the complexity of the model also grows. Designing and analyzing n-PDAs become increasingly challenging, making them less practical for real-world problems compared to the simpler models like single stacks PDA. Thank you, everyone.